So I don't know, मतलब मुझे कल की क्लास बिल्कुल नहीं पसंद आई, so let's forget about that. Morning. So we'll start. Okay. So let's straight away talk about word2vec. Either. So we were talking about the fact that how many neurons will be there in the first layer? Mod V, which is equal to 10K for our example. And then first hidden layer had 300 neurons, and then again the output layer had mod V equal to 10K. Okay. This is a fully connected neural network, right? And this is U for us and this is V. Now, what was our pair example? Glass with water. Okay. So when you input here, what will you input here? So 1 hot vector of glass, what was the number I used previously? So 2893, let's say, and I want my output to be 1 hot vector for water, which was 9329, let's say, whatever. Okay. So this was the case. Everywhere else there will be 0 and so on and so on. Okay. Now, when you input glass, you want output to be water, as simple as that. Now, how was that happening? If you remember, we did this, that only this one. So if you see, even though this is a randomly initialized matrix, when you take output here, we will get output only because of this one, because rest every other weight will be multiplied by a 0. So only, so if we have a neuron here, right, so only this term will on the other hand, this side if you go, दिस इज अ क्वेश्चन जो तुम कभी भी पूछ सकते हो बिना डरे, ठीक है, राइट. सो विल हियर वी हैव ऑल जीरोस एक्सेप्ट दिस गाय मे बी. Will we have all zeros here? No, right? Here we don't have that same situation, but what we are looking for is, why are we looking for this particular green? How many red numbers are here? How many red numbers are here? 300. How many green numbers are here? 300. Okay. So what is special with red and green? Why have I drawn them differently? This represents, I mean, computations that happen because of this word. Okay. And this represents computations that are giving you the output here. You are getting other outputs here as well, but these two things are giving you the output here. Anything else contributes to this output? No. Okay. So this is what we are having. Now, will you have something like, let me choose some other color. So something like this will also happen. Since it's a fully connected network, everybody is connected to everybody in the subsequent layers. Okay. So what is the weight dimension size here? 300 cross 10K, good old way, and here we will have 10K cross 300. Okay. Now, we will have non-zeros here. So how will my vector here look like? I'll get rid of this 9329 now, or maybe it's okay. So how will my vector here look like? Yes. So we will have some non-zero numbers here, right? And so you have some numbers here. What do we want with them? These are just the linear output of this particular layer. How do you convert it to probability distribution? So you take softmax of this whole vector, okay, and then finally you will get PIs. So after taking softmax, right, so after taking softmax I will be left with, so I'll remove this softmax now. I'm assuming I have taken softmax, and then I will have P1, P2 all the way until P10k. One of them will be P9329, right? One of them will be P9329, and I want my network to maximize this number, right? This is the maximum probability. I want this thing to be there. So I want P9329 to be the highest. And how many times you, so this is how you train this network. Remember, this task is a fake task, right? And that's why you call this semi-supervised. Why semi-supervised? This is a fake task. You are never interested in knowing that output of glass is water, output of glass is me, output of glass is 4. We are not interested in that, right? But somehow authors have intelligently able to find this fake task to do what? To find word embeddings, because otherwise if word embeddings are your output, right, then how do you train this in a supervised setting is not at all clear. If word embedding is your output, what does it mean? So if word embedding is your output, that means somebody is already giving that embedding of water is this, embedding of glass is this, but that is something we don't know in the first place. What is our task in this particular problem? Our task in this particular problem is to learn word representations, word embeddings of words. So we can't simply say we have a supervised setting where given a word I have a embedding, right? Because once you have it for your vocabulary, you don't need to do anything. There is no problem to be solved in that case. Okay? I'll stop here for a few seconds and let me know if you have any questions. But in general, what will happen when you are beginning the training? Most likely this will not be your answer. These numbers are random here, so something else is maximized and you need to back prop and so on. Okay. All right. So yes, that's a good one. So you have this one example. You are training this neural network. How many examples do you have? Roughly 4 billion in our example. Okay, because we said our corpus size is 1 billion, context window size is 2. Okay. All right. So finally you have this. Now we were talking about the cost function. So cost function was, 1 by t summation then log p of so let me just follow the notation of the paper, right. I mean, I don't want to deviate from the paper today. So this is log P W, no. Right, this is what we were doing, and what were things here? T here goes from 1 to capital T, and minus C less than or equal to J less than or equal to C, J is not equal to 0. What is this cost function? This cost function simply comes from, so I have just written the final term. How will you get it? See, you have, where is this? So forget log right now. What is this guy? P of Wt plus Jwt. So this was, if you see, this is the context window of T plus minus J. Okay. So the probability that given Wt as the center word, you have these guys as context. Okay. All right. So what is this probability? We have done this in the last class. So I'll simply take this thing. What was the notation we used yesterday? So probability of P C and T we were using. So this was target A, yeah, or let me just use as they are using. Okay, then because otherwise two notations. So this is W0, WO given WI, and this is what? E to the V prime what was this? U, what was this U? O transpose V I, okay, divided by summation. So let's use this W equal to 1 to 10k. We are keeping this 10k. I should have done this mod V, but that is fine. Okay. So this is basically mod V, and E to the U see, my input does not change, right? So my input does not change dot Vi. Is this fine? एक बार देख लो. This is fine, right? So this is what we do. Make sure this is right. Right? Now this is, so we talked about this in yesterday's class, that this is, so how many such pairs do you have? 4 billion pairs, and for all of them you want to maximize this probability. So basically you want to maximize the probability of multiplication of all of them. Why? Because you want to maximize the probability for first pair, you want to maximize the probability for second pair, and for third pair, and for fourth pair. So you have and sitting in between. So what will happen? So pi minus C less than or equal to j less than or equal to c, j not equal to 0. Okay. This gives you the context window, and now this t equal to 1 to t, that gives you the all the center words, and then we just take the average. How do you get this from this? Just take log, right? If you take log, pi's will become summations and rest things remain the same. You will have log p here.
बट हर सेंटर के लिए तो कर रहे हैं जो ये 1 by t वाली जो कंडीशन है तो हर सेंटर के लिए तो कर रहे हैं.
See, 1 by t you can throw away, right? Right. This one?
हाँ ये हर सेंटर के लिए तो कर रहे हैं.
Can anybody help me here? Why do we have this term? Yes. Why do we have this term? So remember, what was our example? Got it? Okay. So our corpus was, please give me a glass of water. So for the first time you will have please as the center word, and remaining two you will have context word, and then so your center word will go from first word in the corpus to last word in the corpus, assuming there are capital T words in your corpus. This comes from there. For every center word you have 2 times C context words. So that gives you so now if C was 2 and if T was 1 billion, this gives us 4 billion pairs. Okay. All right. So all right, going back here, how do we relate these two things? How am I training? Is this setup clear? Okay, so I think we are done. Now, if you see here, so it is, I mean, this term is this. Okay, what's wrong? I mean, what's inefficient with this? If you see, in fact, I should also mark this quantity is this, because in the end you optimize this one, not this one. By the way, why don't we want pi's here? If you see, if you have billions of terms here, billions of terms getting multiplied, so billions of terms that are smaller than, much smaller than 1 are being multiplied. This will give you numerical underflow, right? Computers will not be able to store that small number. One thing, so how do you change that? Just take log, and log of those things will be much in the range of what computers can store. Yes. Yeah, that's a good one. So we have to maximize this. Thank you. Okay. Sorry. Network you are talking about? Yes. हाँ
तो मैक्स यहाँ पे क्या कर रहा है कि जो लास्ट वाली है वो थोड़ा सबका मैक्स मतलब उनपे से मैक्स पॉइंट उठा रहा है.
see what this is doing is, what is that term p of outward given input word? That is p of outward, because my outward is water, input word was glass. I want to maximize this probability. This is what it is representing. Alright, so what is the exact question?
What is the max doing there?
देखो, what is that max doing there? In this case, I have this pair glass comma water. I want to maximize the probability, this probability, given glass as input, water should be my output word. Okay, I want to maximize this. This is nothing but P of W glass in this case, sorry, W water given W glass. So for every pair you are maximizing this probability, because otherwise you won't get this one hot factor. Make sense or no?
So that
Yes. No? Any more questions? So now coming to this, for what is this quantity? This represents every pair, and for every pair you want to maximize the probability of that output word given input word. You want to maximize this. When your second example will come, what will you maximize? Same, WO given WI. When your next word will come, what will you maximize? WO given WI. So that max you can take outside, because what you are doing is, for first word and for second word and for third word, so you have these pi's and maximum sits out there, because this is simply log likelihood, right? You want to maximize this probability for each of these pairs. More questions here? I won't ask you, you ask me. Yes.
एक तरीके से जो मैक्स है दोनों पाई के बीच में है ना,
ये दोनों
पाई के बीच में है ना, तभी वो वाले को मैक्सिमाइज कर रहा है.
I don't get this.
जैसे मैक्स बाहर निकाला,
Right.
तो ये टेक्निकली तो जो ये मैक्स है ये इन दोनों पाइस के बीच में है ना, कि वो जो प्रोबेबिलिटीज है उसको मैक्सिमाइज कर रहा है.
See, this max can be here, but you can simply take it out, because this is something you are doing for every pair. What if WO and WI will be same? You won't have it same here, right? But now it can still happen for words like the. Okay? So, out of 4 billion example pairs that you have taken, a lot of them will be undesirable. And I have not discussed that how do you optimize your training data set. So, for example, if you see, if you have 1 billion words corpus, 70 million will be just the. Okay? because the occurs 7% of the times. So of 1 billion you will have 70 million only the. So you tend to reduce the representation of words like the. Okay. So if you sort English in terms of their occurrence or in terms of their frequency, the first 100 words I think account for 50% of the occurrences or something like that. So top 100 most frequent words in English will appear 50% in your corpus. So of 1 billion words, 500 million will be just the, and, for, and so on. Okay. So tell me, since you have talked about this, tell me, if there is a word there, what should be its representation? And does it help me? Because what's special with the? It can have so many different numbers in its context, right? So the does not give you too much information about context words. Neither context words give too much information about the. A, N, the, for, these words are stop words, so we don't really use them as much. There is a different frequency that is used for them. Okay, but those optimizations we are not covering in this. More questions here. So actually 4 billion pairs that we are talking about, they won't be 4 billion, they will be maybe half of it, or but not exactly 4 billion, maybe 80%, 70%. Yes.
So will these words disturb the network?
Sorry?
Will these words disturb the network or they will?
No, we will see, if you have over representation of a word, that will certainly have an impact on the network. That's why you reduce their frequency. So if the occurs 7% of the times, maybe you will sample it only 3% of the times. More questions here. Is this cost function fine? Okay. And we simply convert this cost function to this by taking log on both sides. That's it. Last time, questions? All right. Okay, so let me see if anything is left. Right. I had probability. Batao. Properties of the cost function. Cost function, I think I am done discussing that from my side, unless you have questions. So see, all this is doing here is you simply maximize the probability. In this case, maximize the log probability. So there should be a max here, right? Maximize. But you know, gradient descent only knows how to minimize. So how do I change this? All I need to do is take a negative here and simply put minimize. That's it. Okay. So that was easy. Now Nitin, questions? Okay. Yes. So let us come back to this particular equation now. I mean, what does this thing represent? What is that U0 transpose? UO transpose, sorry. UOO stands for output. Okay. So maybe I'll write it here for the time being. I'll write it here for the time being and I'll get rid of this. So help me write this one. What was that? E to the power, give me for this example. So what was the term? E to the power U water transpose V glass, and this thing divided by summation. I am not writing what is summation, you should know what is summation. Now here we will have e to the उल्टा है ना. So किधर? Right. So this must be V, this must be V, and this must be U, right? So then EU I transpose V glass. Is this equation fine for this particular example? Right? What is this part? What does this equation represent? The whole softmax or what? What is this term in terms of the outputs of the neural network? So what is this term in terms of the output of the neural network? Output here, right? It is just the output at 9329 place. What about other places? So for example, what will be the output here? Assuming that word is a, it will be e to the U transpose a, glass will remain glass, so V glass divided by same thing, right? Because it is softmax. So for all these terms, denominator is this, but for first one you will have this pink vector, for second one you will have maybe blue. So for second one you will have, so blue is not visible. So this one, okay? Chupra. Fine. And how many terms you will have? 10,000 such terms. This is the output of just one training example. You like it or you dislike it? Why? You are right, but why? So for one training example, you are computing a 10,000 way softmax. Okay? And actually not 10,000K. Actually much bigger, because you will take English vocabulary somewhere close to, I mean at least 50K. So let's say assuming you will take it to be 100K, you will be taking a 100K way softmax for every example. And this is too much. So this idea, even though it is a super beautiful idea, that how will you compute word embeddings, it does not work. It simply does not work, because if your corpus is large, you will have billions of examples, and if your vocabulary size is large, you will have hundreds of thousands of ways softmax for every single example. And this is too much, super slow algorithm. I am still, So what is UT water? So now for the time being, forget this thing that it is inefficient. Somebody has given you extraordinary supercomputer and you are able to compute this 10,000 way softmax easily. Where are my word embeddings? Drop this softmax inefficiency right now. Where are my word embeddings? Where are my word embeddings? Those probability. So this is my word embedding. This whole thing. So what is my word representation or word embedding for one word? It will be the output here. You may not be getting this question. My question is still the same. Where are my word embeddings? We have done all this. We have said if this softmax was not inefficient, and right now we assume it is not inefficient. So our word2vec is complete. We have completed word2vec. My question is, where are the word embeddings? Which one? This one? You transpose this or just this? Just in box? So this whole thing? Just this? This is a dot product, gives me a scalar. So you want a word to be represented by a scalar? No. Remember, when we were making featureized representation of words, we had an axis called gender and so on. We had a lot of axes, right? So UT water, which color it is? Let me colorize. Okay? Or should I not? Not necessary? Okay. So this is your UT water. Where is your UT water vector? Where is UT water vector? Green one. How many numbers are there? 300. So this 300 numbers, this is your embedding for water. Now that's where the beauty of this algorithm comes, right? Because what is it that you wanted to learn? Word embeddings. And if you do it in supervised settings, there is absolutely no way to do this. So they first make up this fake task. What is that fake task? You try to convert this problem into a supervised learning problem. How do you convert? You say that English has a lot of structure. No two words come together without meaning. So if two words are in their neighborhood, right, then it has some meaning. So for example, when we said please give me a glass of fill in the blanks, there are very few candidates for this fill in the blanks. And all those things, so if I ask you, I scored fill in the blanks runs in the match yesterday, how will you fill in this? With a number? With a number greater than or equal to 0, right? So in English, if you talk about this fill in the blanks problem, right, there are very few candidates for almost everywhere, and this fill in the blanks will go all the way until you talk about DeepSeek. Okay. So what is my embedding for water? So it's a 300 dimensional thing now. What is my embedding for water? This green thing, right? And it is U transpose water. Actually U water, because transpose will make it a row. What is my embedding for glass? Glass is red one. So these 300 numbers. Now tell me, what occurs here at 9329? No. At this place, which word occur? Water. So you will have which color? Water is green. No, but not green. So water is this. Now which embeddings are for water? Dark green or light green? Will they be different numbers in general? Which one? So what will be light green? Give me the notation for that in terms of these things. Light green will be V water. Okay. So this is V water. What is dark green? Dark green is U water. Will they be same? No. So what do I do? Which is my embedding for water? U or V? Basically U plus V divided by 2. Okay. So in word2vec you get two representations for every word, input and output. Okay. And you just make them one by adding and so basically taking their average. Something else that you could have done was just concatenate them. So 300 numbers coming from here, 300 numbers coming from there, and your word embedding will be 600 dimensional rather than 300 dimensional. Okay, but this works equally fine. And this particular algorithm had a storming effect in NLP. There are a couple of papers that have proven to be, like nuclear bombs. One was AlexNet, one was word2vec, another one was attention is all you need, one was neural machine translation. These 4 papers in NLP, except AlexNet, they have been very seminal. These papers actually made NLP ahead of computer vision in some sense. Okay. Otherwise computer vision is an easy thing to do. The moment you click a photo, digital thing, it is already a good matrix. So you don't need to convert your input into, so you don't really need to find a representation for your input. It is already there. But for words, it was a problem. Any questions here? अच्छा एक बार बताओ, वो कॉपीज कब देखोगे भाई? टाइम बताओ मेरे को. 2 बजे, 1:30 से 2. हाँ, अरे नहीं, कल की क्लास भी मेरी खराब हो गई यार. मैं हाँ. So is okay. One more thing. So how do you visualize or how do you interpret these 300 dimensional numbers? No, interpretation. वापिस रैंडम बताओ मेरे को. रैंडम किस चीज के लिए? देखो, you started with random, but once you have trained, let's say 4 billion examples on it, now you know water comes in context of glass, right? So these particular numbers are now trained to such examples. Okay. So for example, if you try to plot the t-SNE of these representations, all the numbers will be clustered together, all the vegetables will be clustered together, all the vegetables and fruits will be clustered into subclusters very close by, okay, and so on. All the countries clustered together, and there will be another cluster of their capitals, but both lying together, and so on. There are so many questions that can be asked in here.
ये जो 300 का second layer है
Yes.
तो अगर इसका
If you don't want this to be 300, if you want this to be 50, keep it 50. If you want this to be 1000, keep it 1000 and so on. 300 back in 2013, it turned out to be a good number. So 300 was the maximum word embedding length, if I remember it right, or probably they did it for 600 as well, not sure. But 50, 100, 150, 300 they did for all these numbers, and it turned out that 300 was the best trade-off, because if you start increasing more, your algorithm will be slow. If you keep it lower number, then embeddings will not be rich enough. Okay. All right. So I take attendance. Huh? Vrinda, Amit, Saraswat, Arukshita, Keshav, Kushagr, Adhiraj, Saurabh, Yadav, Saurabh Sani, Ashmit, Disha is not here, Ishan, Arohi, Divyanshu, Amit, Swastik, Niharika, Muskan, Archita, okay, Kanishk, Yashpuri, Riya, Paras, Riya Singh, Vaibhav, Garv, Payal, Melissa, Akshat, Kashish, Nilesh, Rani, Himanshu, Shrishti, Shreyansh, Yash, Astha, Siddhi, Riddhika, Abhinav, Nitin. Chalo, I'll start again sharp at 10.
ये जो लाइट ग्रीन वाला है वी वाटर,
हाँ.
इट इज फॉर सम अदर एग्जांपल व्हेन इट इज वाटर.
See, right now my center word is glass
हाँ वो मैं समझ गई.
and water is in context.
आई एम टॉकिंग अबाउट द इनपुट वेक्टर जिसने अपने सबको जीरो किया, बस 2893 को 1 किया बिकॉज द टर्म वाज ग्लास.
हाँ,
आप जो 9329 लिखे हो इनपुट में, यू आर राइटिंग बिकॉज व्हेन द सेंटर वर्ड विल बी वाटर.
exactly.
तो ये एग्जांपल में ये ग्रीन नहीं आएगा.
ये green नहीं आएगा.
और
In
example
some,
में
so please give me a glass of water. Two timestamps later, I will have water as the center word. हाँ. So this particular light green belongs to when water is my center word. हाँ.